Today we're going to be looking at dividing radicals. For dividing radicals, we have a nice little rule that says we cannot have a radical in our denominator. So anytime there's radicals in the denominator, we have to find a way to get rid of it. This is what we call rationalizing the denominator. When we're looking at example 1, though, first thing we want to do when we're dealing with these is you want to separate these things out to two separate problems, like so. The square root of 3 over the square root of 16. Well, square root of 3, there's nothing I can do with it. But the square root of 16 is a perfect square. Since it's a perfect square, I can take care of that like so. And therefore, this one has been simplified to all that it can be. The square root of 3 over the square root of 4. Now looking here at number 2, I have the square root of 21 over the square root of 3. Kind of like in number 1, how I separated them out as to two separate radicals, I can take the two separate radicals and rewrite this as the square root of 21 over 3. I do that because I know that 3 goes into 21 nice and pretty. So therefore I now have the square root of 7, and number 2 has been simplified. Looking here at example number 3. Now number 3 is a little different. It's got all kinds of stuff going on with it. I'm going to treat this, I have 8 over 4. I'm going to treat these as two separate things. I'm going to rewrite my radicals now as one single radical like I did in example 2. Where I'm going to have 48 over 2. In doing so, 8 divided by 4 is 2 times, well, inside the radical, I'm going to have the square root of 24, because 48 divided by 2 is 24. Now 24 has not been simplified. We always have to make sure our radicals are simplified.
Wait, what are you doing?
So here we're going to look, and we got to simplify the square root of 24. So this 2 out front, he's just going to be chilling out here while we take care of my radical. Inside the radical, I'm going to rewrite this as 4 times 6. And I rewrite it as 4 times 6 because 4 is a perfect square. Since 4 is a perfect square, I can go through and simplify this. So I now have 2 times, this 4 right here comes out of the radical, and it becomes a 2. And then I have the square root of 6 left chilling inside the radical. Now I multiply the numbers on the outside. 2 times 2 gives me 4. So my final answer will be 4 square root of 6 for number 3. Looking here at number 4. Number 4, I can't simplify my radicals. I can't do any dividing and stuff. I have a radical in my denominator. And as I said at the beginning, my rule says I am not allowed to have radicals in the denominator. So I have to do what's called rationalizing the denominator. Rationalizing the denominator. If I'm going to rationalize, that means I have to make my radical go away from the bottom. In order to do that, I need to put a perfect square there so therefore the radical goes away. I'm going to go through and multiply my problem by 1. Anytime you multiply by something by 1, it doesn't actually change the problem. Because you multiply by 1, you're back where you started. But my 1 in this case is going to look a little different. It's not just going to be a 1. I'm going to rewrite this as the square root of 2 over the square root of 2. Because square root of 2 over square root of 2, that's the same thing as 1. Anytime you have the same number on the top and the bottom, they are still 1. So when I multiply this thing straight across here, I now have 12 times the square root of 2. And here on the bottom, since I'm multiplying, this becomes the square root of 4. I can now simplify that square root of 4. So the top, he's just chilling up top here. Trying to say, hey, what's going on down there? Well, we're splitting up here. Square root of 4 becomes a 2. Now at this point, I can do some division. Because 2 does go into 12, nice and pretty. Since that is a number here on the bottom, I can take and divide these two right here. So in dividing those two, I'm left with 6 square root of 2 as my final answer. So looking here at another example, here I have square root of 3 over 7. So first thing I'm going to do is I'm going to rewrite this thing as two separate radicals. Square root of 3 on top of square root of 7. Again, I can't have a radical in my denominator, so I need to make that denominator become a nice, pretty number. So I'm going to give it a makeover. Makeover I'm going to do by multiplying by 1. Call this thing a magic 1 sometimes because, he makes things look different, but he's still the same. My magic 1 is going to be whatever's in my radical in the denominator. In this case, it's a 7. So square root of 7. Square root of 7. So when I go and do my multiplication, I now have the square root of 21 over the square root of 49. So, square root of 21, I can't simplify it, do anything to it. He's just going to be chilling up top. 21. Square root of 49, that is 7. Stick a fork in that bad boy. He is now done. Looking at example 6, same thing we did right here with example 5. We have one less step, though, because it's already separated as to two separate radicals. So I just got to stick me a magic 1 out here beside him. My magic 1 in this case is going to be the square root of 11 on the top and the bottom, which this gives me the square root of 55 over the square root of 121. So square root of 55 on top, 11 goes on the bottom. Stick a fork in that bad boy and he is done as well. Simplifying radicals with division. Remember that you have to go through and make sure there are no radicals left in your denominators. As always, pay attention to what you're doing, and good luck. Bam.